Dear students, good morning. In this class, we are going to start about database programming. This is Unit 5 using Python. First, let me see the basic concepts of databases. Okay, in this class, we are going to see what is meant by a data. Okay, what is information? What is meant by a database? What is meant by a database management system? And what are all the different types of database management system available? And which one is having very good market share in the current trend. Okay, which companies are using which type of DBMS software. Okay, in this class we are going to discuss all about. Then later we will skip into how to write, how to connect databases by writing the Python program. Okay, this is our idea. In this class, first I'm going to introduce you the basic concepts of database, programming. Let me start with what is meant by a data. Data is nothing but data is a raw fact about anything or object in the real life. Actually, it is a raw fact. Otherwise, we'll call it as it is a unprocessed data or unorganized data, unrefined data. Okay, it is nothing but raw facts about a thing. We will call it as a thing in the real life. Usually, a thing in the real life will be known as a object or entity. Okay, unless you process this data, it is not going to be useful. So data is in the format of unorganized, unprocessed, and unrefined in that way. What type of data will be there? Usually we know already data can be a number, data can be in terms of a text, because it may be a collection of character strings. Otherwise, it may be a single character. Numbers means it may be an integer or it may be a floating point, decimal numbers. Okay, other than that, nowadays we are started storing the data in terms of images, audios, and videos also. Because of the revolution of social media, we'll be having different types of data. The basic data is going to be a number data, it may be a text data, it may be any image, audio, or video. These are all the different types of data available. Okay, it is nothing but it is a raw fact about a particular object or entity, unorganized, unprocessed, and unrefined data. Unless you process it, it is not going to be useful. So we will say data is basically useless unless you apply analysis processing on that here. Let me see the examples here. Let me take the student object, in the real life. Okay, we know every student will be having some hall ticket number or roll number, which is unique to each and every student. So I can call it as roll number is one of the data. We know what is the type of roll number. Usually roll number is a alphanumeric. So we are going to call it as it is a string or text data. Next one is here marks of a student. Usually marks is going to be a number, which is a floating point or a decimal number. Then you take the employee entity or object, employee salary. Salary is consists of rupees and paise. So it is going to be a number as well as it is a floating point here. Then you take the cricket. Okay, when you take a cricket here, the runs scored by a particular player. Okay, irrespective of the format of the game. Okay, what may be the runs scored by a particular player? Runs is nothing but which is going to be a number, but it is an integer. Then you take a football or hockey, how many goals scored by that particular player, that is also going to be a integer, which is a numeric data. Like this, data will be of different category. It is going to be a different type of data is available here, which is nothing but a raw fact about an entity or object. This is example for data. Now let me move to information. Information is nothing but processed data is known as information. Otherwise, we will call it as a organized data or structured data. Processed, organized, or structured data is known as your information. So once you have to collect the information, then you have to process it. Then that processed data, information only actually useful for decision making or for any other purpose. You can use that particular processed data. First, you collect the data, pull the data in the real life, and you process it. Okay, you organized it, you structured it. Then that will become as a useful. Such a useful data will be known as a information. Now you see, I have given two examples here. The first one is with respect to the students. First, okay, question is here, query is number of students with marks above 80 in Python. I took one, okay, course or subject Python. Okay, just I'm having, okay, marks of every student in the Python. Okay, just I want to see how many students are scored above 80 in Python. Then I will call it as a information. Assume that particular company is looking for a candidates, those who scored above 80 in Python, then this data, okay, processed data will become useful. So I may call it as a information. Now let me take the second example here, which is nothing but a employees here. Employees with the salary less than 50,000 per month here. Okay, based on the salary, I'm filtering, okay, that particular employees here. Those who are less than 50,000 per month, those who are above 50,000 per month here. Okay, like this, okay, by taking the raw data, I'm processing, okay, that process structured or organized data will be known as a information. Information only will be useful if you want to take any decision making in the real life here. So now we have seen two terminologies, basic terminologies in the databases. First one is the data, start with data. Second one is the information. Now let me split, okay, so we'll go to the third one here known as databases. What is meant by a database? Database is a collection of related data. Okay, collection of related data which is organized. Usually that should be organized, will be known as a database. For example, you say student database. What will be there in the student database? Will be having roll number of a student, name of a student, mobile number, okay, mail ID, the year he or she belongs to, branch, attendance percentage, marks. Like this, will be having so many, okay, data about the particular student. So you can pull all this related data. You can call it as a student database here, which is organized. Next, we will go for a employee database. Employee database. Every employee will come with the employee ID, designation, okay, qualification, salary, the nature of work the employee does. Like this, these are all the attributes or the data about the particular, okay, employee. So we will call this as your employee database here. Now we'll go for a product. When you go for any shop, otherwise whether it is offline or online, okay, when you are trying to, okay, procure a product, each product will be having the product code. Each product come with the title or name, the price. Okay, these are all the data about the product. Like this, you can take some entities or objects in the real life. You can pull the related data for the particular object or entity. You can call it as a database here. So database is a collection of related data which is organized here. Why we want databases? Because if you pull the related data about an object only, that can be stored efficiently. You can retrieve the data, you can modify, you can insert, you can delete, you can search. We can do a lot of data processing, okay, by using the database only. So put everything related to that particular object into a pool, then you call it as a database, like the student database, okay, employee, okay, database, and okay, product database here. Okay, next we will go to database management systems or DBMS. What is DBMS? DBMS is a software actually. What is the use of this software? Which is used to store the data into database. Okay, which is used to insert the data, delete the data, search the data, modify the data. If you want to do anything with respect to that particular, okay, database, all those things can be done using database management system. Database management system is basically a software, okay, which is designed to do, okay, various operations or manipulations on database. What we can do, what kind of manipulations you are going to do, what kind of operations you are going to do: creation of a database, creation of tables, okay, inserting the data, deletion of your data, modification or updation of your data, searching of a data, grouping data. Like this, we can do a lot number of operations on a database using database management system. Okay, not only that, basically, the end user can interact with the database only using the DBMS. So we can call it as it is an interface between the database and the end user. How the end user is going to interact? We are going to interact through the program only. Assume that you will be using any one of the app in your mobile, or if you are interacting with your desktop or laptop, then what will happen by the time you are going to interact through only the software. Okay, one certain app is a software, otherwise you'll be having some website, or it may be a desktop based software, okay, where the user can interact with the database only through the program here. So using the program, the end user can interact with the database using only DBMS. Okay, whether it is going to do only that much operation done by the DBMS, not. Other than interaction from the end user to the database, DBMS also do lot of tasks here. Okay, DBMS is useful to back up your database. If there is any failure, then using DBMS software, you can recover that particular database here. Okay, you can create different logins, you can monitor. These are all the works of usually a database administrator. Whenever there is a database in the real life, in the companies, we'll be having database administrators also. The role of database administrator is here, taking the backup. Whenever there is a problem, recovering the particular data, lost data, creating different users, giving the privileges for different users, all those things will be done. All those operations also can be done using your DBMS. Okay, two ways it is going to be useful. Okay, you are going to control and monitor entire database and its user using the DBMS software. And the second thing is you can do basic DBMS operations such that, okay, database operations such that insertion, deletion, updation, modification, such. Okay, so that sort of operations also can be done. This is DBMS, database management system. We have seen 4 different things now. Data, the second one, okay, how to move from data to information. Now the third one is a database, how you can pool the related data, organize it and call it as a database. And the fourth one is the software which is required to work on that particular database, which is known as a DBMS here. Now we are going to see what are all the most popular types of DBMS softwares here. Okay, we have hierarchical DBMS, network DBMS, relational DBMS, and object oriented. Just I took here 4 main types of database management systems. Other than this, we have number of other DBMS also. But most popular 4 main types of DBMS softwares are here: hierarchical, network, relational, and object oriented. 4 different types of DBMS, database management system softwares. First, let me move to hierarchical DBMS. Okay, how the database or the data will be stored in the hierarchical DBMS. Okay, already you come across in the data structure, there is a concept known as a tree. Okay, tree is what here? Tree is a hierarchical data structure which stores the data in terms of nodes. Okay, we'll be having one node will be known as a root. That will be the first node of your tree, and the root will be having number of children. Okay, then we will go different levels here. It is a hierarchical data structure. Like this, in the hierarchical DBMS, the data will be stored in hierarchical tree-like structure here. Okay, tree-like structure. Now you see the given example here. The first node here, it is known as a root node. Okay, then I'll be having, you see the children of root node. I'm having 3 children here, 1, 2, 3 here, Mayan, Mary, and Gami. Like this, I have 3 children here. Again, John is a child of Gami, and you see here, Jake is a child of Mayan and Mary here. Okay, like this, we'll be having a structure which is a tree-like structure here. Okay, hierarchical structure. So here the data will be represented in terms of a parent and child relationship. Okay, you know already a tree can be a general tree, otherwise it may be a binary tree also. Here we consider general tree. Okay, general tree means here what? A node can have any number of children. Now you see the root node. My root node is having here 3 children. So it is a general tree structure. Suppose if you go for a binary, every node can have maximum of 2 children only. That is nothing but a binary. Here in this case, I took here general tree structure. But if you see, every okay, child will be having some parent. There is a parent-child relationship here. Okay, Gami is a parent of John. Then you see root node is a parent of Gami. Then I can call root node is an ancestor of John. Okay, like this we can make a relations here, parent and child relationship. This is a way using the tree data structure, hierarchical data structure. The data will be stored in the hierarchical DBMS software here. Okay, which softwares, which DBMS softwares are based on this hierarchical? We have two types of popular hierarchical DBMS softwares. From IBM company, we have IMS. The second one is here for mobile database, they will be using RDM mobile DBMS here. This is about hierarchical. Next, we go for the second type of DBMS software, network model. If you see the network database model here, each child can have multiple parents. It is also somewhat parent-child relationship only. Here you can have multiple parents here. Like I can say it is a kind of a graph. You know what is meant by a graph here? Okay, graph will be having the nodes. Well, the nodes are connected between using the edges here. Like this, using a graph kind of structure, data structure, we are trying to represent the data in the network model here. Here, what will happen is here, you can take a more complex relationships. Like this, we have different types of relationships, one-to-one, one-to-many, many-to-one, many-to-many relationships here. So if you want to represent here, many-to-many relationships here, that kind of relationships can be represented very easily in the network model DBMS software here. Now you see, we have the salesman, invoice, customer, payment, invoice line, and product. Okay, here it has been mentioned, you see here 1:m here, one-to-many. Okay, one means here one-to-many relationships. Otherwise, you can say m-to-m. Okay, many-to-many, many-to-one, one-to-many. Like this, we can represent 4 different type of relationships in the network data model. So it is going to be a bit complex than comparing to your hierarchical data model here. Okay, the examples, which DBMS softwares in the real life, they are using this particular network data model. You see Turbo Image, IDS, Integrated Data Store, RAMA Database Manager, Univoc DMS 1100, IDMS, Integrated Database Management System. These are all the examples of DBMS softwares which are based on network data model, where they are going to represent the complex relationship like that many-to-many here. Okay, these DBMS softwares are designed where if the user creates any data, in this case, they are going to be stored in the network data model here. A third very popular data model is nothing but here relational model. We will call it as a RDBMS, Relational Database Management System software here. What is the basic thing? How they are going to store the data? In the relational model, very simply, they are going to store the data in terms of a table. We know the table means here we'll be having the rows and columns here. Okay, now you see one example I have shown here, customer information. What are all the columns here? Customer ID, first name, last name, address. Okay, I have given here 2 customer data also. Here one row will be known as here one record. Okay, each row is one record. It is about one object in the real life. See the first record, first row is here. Okay, the data about the customer, John. Second one is nothing but here the data about the customer Susan. Okay, each row is going to represent one record, which is nothing but here the data about a particular customer here. Okay, each one. Now, if you see the columns here, we will call the columns as attributes or characteristics or properties. What the properties of a customer? We considered here customer ID, which is unique. No 2 customers can have the same ID, unique. Okay, which is not duplicate. The second one is what here? First name. The third column is last name. Okay, the fourth column is here address. Each column is known as attribute. Attribute means here what? The property or characteristics of that particular object or entity. Our object is your customer. Okay, I have four, I considered four attributes, so I'm having four columns. Here in this case, I took only two customer data, so I'm having only two. Now you see the first one, customer ID is denoted as a primary key. Okay, what is meant by a primary key? Okay, out of these columns or attributes, one column or more than one column is going to be unique actually. You see the customer ID is unique. No two customers can have same ID. If you insert the same customer ID for one more person, then your relational data model is going to throw error because that has been designated as a primary key. For example, you take student, which one we can take? We can consider roll number as a primary key because no two students can have the same roll number. Then we will go for an employee. Employee ID is a primary key because no two employees in an organization can have the same ID. Like this, if you take any entity, object, or thing in the real life, every object will be having a particular property or attribute which is going to be unique here, which cannot be repeated for more than one record. Okay, such an attribute, in case, okay, one attribute, in few cases it may be a combination of two or more also. Okay, by combining two or more attributes also, you can create a, okay, primary key here. Okay, this is about a relational model, which is very popular model used in, okay, used in to store the data in a database format here, used by many of the companies in the real life also to store the data because it is very simple to process. It is going to use the tabular format here, two dimension like a matrix, which will be having the rows and columns. Each column is one attribute. Each row is nothing but here one record. Such a way we can use. In most of the relational database management system software, they'll be using a language known as SQL. That is known as structured query language. It is a structured, okay, structured, then only it is a database, then it is a query. Query means yeah, a question, a language. Like any other programming language, it is also a kind of a language which is, okay, developed and it is meant only for dealing with the, okay, Rdbms software. So SQL will be the part of every Rdbms softwares. Now you see the examples. Okay, IBM is having, okay, DB2 database, which is a Rdbms. And you take the Oracle Corporation, they are having the Oracle Rdbms software. Then Microsoft is having SQL Server. And if you go through the MS Office, as a part of your MS Office, you will be having MS Access also. That is also a kind of a, okay, software only, okay, Rdbms software. This, the IBM DB2, Oracle, SQL Server, these are all proprietary softwares because, okay, we have to pay money if you want to use them. Now you see the next two, MySQL, which is a Rdbms software, but it is a free open source. You can download, you can start using it. Next one is here, PostgreSQL, which is also a Rdbms software, but it is a free software here. Okay, these are all the very popular Rdbms software used, okay, in the real life, day-to-day life by most of the MNCs to store the data in the tabular format. DB2, Oracle, SQL Server, MySQL, PostgreSQL. Fourth type of, okay, DBMS model is object-oriented model. We know already, our Python also what? It is a object-oriented programming language. Java is a object-oriented programming language. In Python, if you take, everything is an object. Okay, object is what? We can define object in different ways. If you want to define an object, define is, okay, object is nothing but here, any entity or thing in the real life. I can say student is an object, computer is an object, okay, mobile phone is an object. That is one way of defining. If you want to take, okay, consider it. Otherwise, technically, if you want to define, already we completed object-oriented programming, classes and objects. Object is an instance of a class. That is the way technically you can define an object here. So if you go for object-oriented model of DBMS, here the data will be stored only in terms of objects. So that we'll be having the concept known as here, the classes. then object will be created. The data stored only in terms of a object here. So the component of this kind of DBMS is going to be the object through which we are going to store and retrieve the data. Already we know if you go for any class, the class is a data encapsulation unit which has members, means variables, as well as the methods or functions. Okay, methods or functions you can use. You can use members or variables. Already we have seen number. For example, employee you take. Okay, what may be the members for employee? Employee ID, name, salary. These are all nothing but variables or members, data members. If you go for operations, what operations you can do? Insert employee or add employee, delete employee, search employee, update employee, display employee. Like this, you can perform number of operations. Put together, you can call it as a employee. Okay, so you can have an object known as an employee, which is having data members or variables and as well as the operations. So when the data is stored in this kind of object oriented model DBMS software, it is going to be stored only in terms of objects. Now you see the examples: Versant, object store, object DB, Perset, concept base, object database plus, Wakanda, objectivity or DB. These are all the different object oriented based DBMS softwares. Just we discussed 4 main types only here. Okay, what is the first one? Hierarchical, which is going to use the parent-child relationship similar to a tree in a data structure. You can use a general tree structure, otherwise you can go for using a binary tree. It depends upon the application you are going to work here. Hierarchical. Second one is the network DBMS software. In the network DBMS software model, we are going to represent the complex relationships here, many-to-many relationships, so that here it is going to be a kind of a graphical structure where the data will be represented using the nodes and edges here. That is the way network data model works here. The third one is the most important kind of model. We'll call it as a Rdbms here, relational model, where the data is stored in terms of your tables, rows and columns here. Okay, here if you see, the majority of the companies will be using the relational DBMS model only to store the data. Very popular are IBM DB2, Oracle, SQL Server, MySQL, PostgreSQL. Few of them are proprietary software. Quite a few are here free softwares here. The fourth one is how nowadays every language is coming with the concept of object-oriented programming. Databases also coming with the concept of object-oriented modeling, where the data will be stored in terms of your object. Object is an instance of a class, where each class will be having data members or variables as well as the operations here. These are all the different examples for object-oriented DBMS software. Okay, now we are going to see, how the global database market looked like in the year 2022. Okay, they analyzed the last 4 years, 2017 to 21. They consider 4 years of data. Okay, they pull the data from different MNCs which are in the globe. Okay, different companies. Okay, which are using the databases, because nowadays most of every application require a database to store the data. Data is very, very important. They pull the data last 4 years, then they generated this kind of report. Now you see here, the market share by type. We have 3 types they mentioned here. The first one is the relational database. You see the relational database, that color you see, relational database here. Majority of that particular market share is dominated by Rdbms software. Just now we have seen which are all the Rdbms. Rdbms store the data in terms of your tables, DB2, Oracle, MySQL, SQL Server. These are all the examples for Rdbms softwares here. Majority of the companies are using relational database models, means they are using tabular format to store the data. Second thing is here, no SQL. No SQL means here, they won't use not SQL actually. It is not a SQL or not only SQL. We are having different expansions for no SQL. Okay, all the relational databases will use the SQL, structured query language, if you want to do any kind of data processing. No SQL means they will not use any structured query language. They will not store the data in the tabular format. They will store the data in different formats here. Every NoSQL software is having their own way of storing the data here in terms of your documents. Okay, like this, they will try to store that particular data. The second majority, okay, market share is goes to NoSQL. Third one you see, okay, a small percentage goes to other Rdbms software. Just now we have seen what are the Rdbms software is important here. Okay, other things are nothing but here. Okay, object-oriented, network, hierarchical, any other thing, okay, which are using different concept to store the data. Those are going to be the remaining market share. But you see, majority of the market share still dominated by the relational databases only. Relational databases uses here the tabular kind of structure, row and column structure to store the data about a database, about a particular object in the real life here. So what we are going to do is here, because relational databases are most important, in that we are having two popular. Oracle is one of the very top, okay, RDBMS software, but it is what? It is a proprietary software. But okay, next thing is MySQL. Second market share in the RDBMS is here MySQL. First two, okay, for topper is okay Oracle. The second one is a MySQL. MySQL is a free software. So what we are going to do is in the fifth unit, we are going to consider the open source or free software known as here MySQL. Okay, we are going to see, okay, what is MySQL, how to create databases, how to store, how to perform different operations, okay, search operation, deletion, updation, like these kind of operations, how to do in your MySQL. We have to, okay, now in this class week, okay, just okay, we have gone through the basic concepts: data, information, database, DBMS, different types of, okay, most important 4 types of DBMS models, and how the market is look like, how the global database management system market look like, which type of, okay, DBMS software is more popular. So that because of the popularity, I'm going to consider in this class, okay, in the forthcoming classes, I'm going to deal with, okay, relational databases. In the relational databases also, I'm going to consider MySQL DBMS software, which is a, okay, free software here. If you consider any relational databases, all of them will use a common language known as SQL, structured query language. Okay, depends upon a software, it is going to be a bit vary. Data types may vary. Okay, a few things are going to vary. Other than that, SQL is going to be a common for all the relational databases. In the SQL, we'll be having data definition language, data manipulation language, data control language, and transaction control language. Like this, we have 4 different types of languages. Okay, all these 4 languages pooled together, we will call it as a structured query language. So by considering, okay, MySQL in the next class, we are going to see MySQL history, different data types available. Then we are going to discuss about how to do these DDL, DML, DCL, and TECL operations on MySQL. After completion of, okay, introduction to MySQL, then we will see how to write a program in Python, how to connect that, okay, Python program to the MySQL. By that time, we will call Python as a front-end program, MySQL as a back-end here. This is, okay, the view. This is the way we are going to proceed this particular unit 5. Okay, I like to thank every one of you for your patience. Okay, we will meet in the next class with MySQL introduction. Thank you.